So could you guess what the next one would be? And I'm sure you could. It would look like what we had previously, which is right here, except instead of a 4, we'd have a 5. Now we could keep doing that for every possible number of coins, but that would take forever, right? You'd work your way all the way up to like 88.66 plus 0.62 times 171,931 coins. And you would be there literally forever writing out all the possible coin numbers because you could just keep adding coins into this bucket. Or if it was an infinite bucket, we could just keep adding coins. So what we want to do is we want to look for a pattern. And we want to see if there is a way that I could write a mathematical sentence to describe what the next one would be for any number of coins, not just the fifth coin or the 171,000th coin, but for any number of coins. So if we look at our pattern here, it looks like every time we see 88.66. So I bet you the next one's going to have 88.66. So I'm going to write that down. Next one after that, I bet you the next one's going to have a plus sign because it's in every one of those up till now. And it's also going to have a 0.62. It's also going to have an equal sign. Here's where things get a little crazy because we notice that things are changing. Here, 1, 2, 3, 4, the number of coins is changing. So what would we write in here? We can't write a specific number because we want to avoid that trap of writing numbers over and over again. So we could write a word, like we could write coins. Wow, that was a nice N. Except the problem is we know that as mathematicians, you might call it lazy, but we're just efficient, right? We don't want to write this big word over and over again. So what we're going to do is we'll just write C for coins. And then over here on the right-hand side, and you guys all picked different variables when we were doing this investigation, and you can pick whichever variable you like, that's fine. As long as you know what it stands for, and we'll talk about that in a second. Here on the right, we have what would be the total weight, so we'll just call it W for weight. Now, before you go on any further, what you would want to do is you would want to make sure that if all that you had was just this equation, if you just had this equation right here, would people know what you were talking about? So what we would want to do is make sure that we had a way to tell people what those were. So you could say C is number of coins in the bucket, and W is total weight of empty bucket plus coins. Okay, so now we've clearly defined our variables. We know what those are. And that looks like you got a great equation there. And hey, look, we're actually looking at lots of different numbers, right? And what is one of the ways that we said that we could represent relationships between numbers? And that would be equations as one of them, tables and graphs. And before we set out on this whole thing, now that we've arrived here at an equation, that tells us something important, that if you didn't see it before, we know that there is a relationship between the number of coins in the bucket and the total weight. If there is a relationship between any two numbers, then you can represent it with a graph, a table, or an equation. You can do a lot of good math with that. Remember, like we said before with the robot cars, telling the past, telling the future, answering questions about the right now. And this one's no different. So sometimes what you can do is if you want to study something, determine, like for example, how many coins are in the bucket, you find a relationship, almost like you force a relationship that's there. In this case, the weight, we're going to find a relationship between the number of coins in the bucket and the weight. And that was second nature to you guys because when you walked up to the coin bucket, you grabbed the coin bucket and you kind of held it in your hands like, hey, I want to see how heavy this is because that might tell me how many coins are in the bucket. So let's now look at the math that you guys did here with the subtraction and the division, and look at what happens when we take a look at all of this. I'm going to see if I can get this onto another page here. What happens if we look at all of this in relation to the equation that we had? So check this out. We're going to hopefully minimize this to, and hopefully you can still see that. But now let's look at our equation And look at how it relates to the math that we just did, okay? So we're going to take that equation that you just wrote, which is 88.66 plus 0.62 times C is equal to W. And you know what, we can answer a couple really good questions about this that might pop up, such as, for example, how much would the bucket weigh if there were, let's say, 541 coins in it? Okay. So we'll take a look. How would we know that? Well, looking back, I mean, how did we know that there were the weight for 2 coins or 3 coins or 4? And it looks like we just multiplied that number of coins times 0.62. We added 88.66 to get the final weight. So looking at that here, if we were to do that again, it looks like we would be using this equation and multiplying 0.62 times that number here, which is where C is. So in essence, what we're going to do is we're going to, if you remember how you defined your variables, as you guys said, C is the number of coins in the bucket. So looking here, it says, you know, what would we do if there were 541 coins in the bucket? Well, you know, we're going to take 88.66 plus 0.62 times 541, and that's going to help me figure out this variable here, W, or the weight. So what would that look like? Let's go over to our calculator. 88.66 plus 0.62 times 541. And it should weigh 424 grams. Okay, so that is going to be equal to 424, approximately, I should say, 424 grams. So then, you know what, that's great. I mean, it would tell us a lot of different things now that we don't have to do. We don't actually have to weigh 541 coins. We can just see how much it would weigh through our equation.